Welcome back to Physical Science 20. We just finished talking about phase, in phase and out of phase, so we'll look at period and frequency. Although wave speed and amplitude can describe both wave pulses and periodic waves, period applies only to periodic waves. So you've learned that period. So if we look at a pendulum moving back and forth, the time it takes to do one complete cycle would be period. We can also use that with waves. The period of a wave is equal to the period of the source. And more importantly, what is it exactly? It's the time it takes the source to complete one full cycle. Okay? So the time it takes to make one complete movement is the period of the wave. If you look at the next page here, there's a couple of things we should copy out. So period, big T is the variable used. The number of seconds per number of cycles. So if we made... if it took 10 seconds to make 5 complete cycles, 10 divided by 5 is 2 seconds. 2 seconds per cycle would be the unit of measure there, or simply seconds. Frequency, now you can see these are reciprocals of each other. Seconds per cycle, cycles per second. Frequency is the number of complete oscillations or movements a point makes per second. So complete movements per second. So we can see here that the unit would be cycles per second, or 1 over seconds, or seconds to the negative 1, or just simply Hz, which is short for Hertz, named after Heinrich Hertz. Okay, so the number of complete cycles per number of seconds. So we can see how are they related to each other. F is equal to 1 over T, or T is equal to 1 over F. If I know frequency, I can get period by taking 1 divided by F. Okay, so get those down, folks. Calculating wavelength. You can directly measure a wave's wavelength by measuring the distance between adjacent crests or troughs or other points on a wave. You can also calculate it because the wavelength depends upon both the frequency of the oscillator, the thing making the wave, and the speed. And the time interval of one period, a wave moves one wavelength. Therefore, the wavelength of a wave is the speed multiplied by period. Using the relationship that F is 1 over T, we can also write it this way. V is equal to, lambda is equal to V over F. Or if I rearrange for V, which is most often what happens, is V is equal to lambda times F. That is referred to as the universal wave equation. Or knowing that F is actually 1 over T, substitute 1 over T for F, and I get that. So write down both those, very important, and you'll have those available at all times. Graphing waves. If you took a snapshot of a transverse wave on a coiled spring toy, it might look like the wave shown in figure 10. So something like this, or I guess figure 10 is back here. So we could see that. This snapshot could be placed on a graph grid to show more information about the wave. As in the left panel of figure 11, measuring from peak to peak or trough to trough on such a snapshot would give you the wavelength. So if we looked from trough to trough or crest to crest, that would give you that information there. And we can measure it here from 0.2 to 0.6, so obviously it's 0.4, 0.4, etc. We could actually measure it. Now consider recording the motion of a single particle, such as a point P in figure 10. That motion can be plotted on a distance time graph as the right graph in figure 11, measuring from peak to peak or trough to trough, and this graph provides the period. So that just goes to show that we can just measure all this stuff. An example here, which will lead to an assignment that we're going to work through together here, and then of course there's a hand-in assignment that you'll do. So these we'll do for practice, and then there's another one that we're going to hand in. So characteristics of a wave. A sound wave has a frequency of 192 hertz, which is, of course, yes, 192 cycles per second, because that's what frequency means. It travels the length of a football field, which is 91.4 meters, and this takes 0.271 seconds to happen. What is the speed of the wave? What's the wavelength? What's the period? If the frequency were changed to that, what would the new wavelength and period be? So we could sketch it like that. The things that we know the frequency, it's 192 hertz. We know the distance it traveled, 91.4 meters, and we know time. So we know these three variables here. We're asked to find speed of the wave, V, wavelength, lambda, and period, big T. So if we know frequency, distance, time, we're asked to find speed. Of course, yes, look at that. Just like in Science 10. V is equal to d over t. Speed is equal to distance over time. 91.4 divided by 0.271, 337 meters per second. Okay? Wavelength, we know what speed is. We know frequency. So if we know speed and frequency, we can see here we can get wavelength. Or this equation rearranged, wavelength is equal to speed over frequency. So lambda is equal to V over F, 337 meters per second divided by 192. Now 192, that's actually seconds per -1, which cancels with this seconds, which leaves us with meters. So that's 1.76 meters. And then lastly here, or third lastly, what is the period of the wave? If we know what lambda is, or hey, we know what frequency is, right? So if we know what frequency is and we're looking for period, there we go, T is equal to 1 over F. So if you want, you may want to summarize these equations on one page so you have them. 1 divided by 192 is, and then 3 sig figs. The 1 doesn't count in terms of sig figs, so that's 3 sig figs, 0.00521 seconds. And then the last variable here, what is if the frequency was changed to that, what would the new wavelength and period be? Okay, so we're assuming that we're traveling at the same speed here, but if we change the wavelength, or sorry, if we change the frequency, so we have the same speed, change the frequency to 442, the wavelength is now 0.762 compared to 1.76, so we can see it got smaller. And then what would the new wavelength, okay, and then period, period is equal to 1 over the new frequency is 442, so decimal 0.0226. Okay, so that is a question involving dealing with all of these formulas. So the ones you should have written down on maybe a piece of paper, V equals D over T, how you determine frequency and period, how did they relate to each other, and then lastly the universal wave equations. Okay? So for the final part of this, the third part of the video, folks, we'll do some of these practice questions together, and then you'll be able to finish this first assignment here, which is this one. You have a separate booklet, Wave Properties, some qualitative questions on the first page, and then some problems, calculations on the second page. So that will correspond to what we're doing with this booklet. Okay, see you again.